Project ACESO is a tool for physical therapists that is designed to help them treat their patients more effectively. Named after the Greek goddess of healing, ACESO, this project is the senior design project for 5 students at West Virginia University. And the way these students plan on implementing this tool is with a device you might already be familiar with.
When the Wii first came out, I thought, oh, this is a very cheap sensor that we can just put on the person and record their movements anywhere very quickly, very cheaply. And then Kinect was kind of the next best thing, because Kinect records the whole body motion in 3D. When the Wii sensor, we would need multiple, and it would be a wearable system.
We heard this great presentation from Dr. Gritsenko during our second week of senior design. I believe it was the second week. And that sold us on the idea of getting on board with this Kinect game that she was wanting to have implemented.
Starting a series of research projects that are aimed at improving the physical therapy and especially bringing physical therapy into rural communities, into patient homes, making the physical therapy more accessible to people with neurological disorders and other medical problems that impair their movement.
But how exactly do they plan on making this project work? ACESO is an acronym that stands for the Automated Capture of Exercise Statistics for Output, and the primary objective of the project is the creation of a system to facilitate physical therapy. The idea is to have patients playing a fun, docile game where the prescribed motion and exercise for their therapy acts as the controller. Behind the scenes, the game will be collecting useful data for the therapist to monitor patient progression. Within the main umbrella of Project ACESO, there are 3 sub-projects: the API, the statistical backend using a MATLAB interface, and the game design.
What we want is a way to have data from the Kinect make sense. The original idea was actually an API, which is essentially a library of functions that you call within computer programs. That has evolved over the past few weeks to be an actual standalone program that essentially takes the Kinect data and makes it accessible for a variety of programs to use.
Whenever you have processes running, we have things called threads, which can run in the foreground or the background. A foreground process will take user input, give out the output that the user needs, anything you usually use on a computer. A background process does things without the user needing to know anything. It will collect data and perform operations for the computer to use, and then send it to another process if needed.
All the software libraries and all of the primary resources are all written in a language called C#, and that's actually what makes the Kinect do its thing, which is it looks out at the world and then it tries to map a skeleton to a person it's seeing with its camera. Whenever you have a new patient, you know, if someone has had a stroke or nerve damage, as I've mentioned before, you know, they might have a more limited range of movement than most people would, you know. So like you and I, who haven't had, you know, any serious injuries, can, you know, move your wrists relatively freely, you know, whereas someone who's had nerve damage in the arm or a spinal cord injury, you know, might only be able to do, you know, like a fraction of that movement.
But basically you're going to have the patient come in and do a quick session before so they can get their actual range of motion, and then that way that system, what it will do, because, you know, it'll have a normal range and then it'll change it, calibrate to theirs, so that way when you move on the screen it'll pick up their range of motion instead of the real range of motion.
So the calibration takes that angle and says, okay, this is your normal, so that when you play the game, you know, it's not asking you to go this, it's just asking you to go that.
We're trying to get a MATLAB interface for the Kinect so that kinematic data can be modeled.
Really, it's basically just to help visualize what's going on. I mean, that's the end game for the MATLAB part. That lets you look at the actual data that's being collected. So the patient's playing the game, that's what they see. What the doctor has to look at for progression or regression is the actual data from restricted movement or whatever, and that's what the graphs will allow them to see.
I wanted something that was preferably very captivating, unique, looked really good and pretty, but it's a rehab-oriented game, so I thought, well, one of those characteristics should be relaxing. It should be easy to play. Well, what's fun to do, and it's pretty relaxing. I was like, well, watch trees. I was like, how can you make a game out of watching trees? I was like, well, you can make a game out of shaking them. There are these cherry blossoms that are spaced out everywhere on my walk to class from my house. And one day I was walking to class and saw the petals falling from the wind, and I was like, there's my game idea. I'll make a tree, and then any limb, no matter what it is, can do a shaking motion or go through the prescribed motion for their therapy, and how accurately they do the motion will affect how beautiful the game becomes, how many leaves that are coming off the cherry blossom. So there's a visual incentive to want to do your therapy right.
That was our first initial design for a game we wanted to do, where we would have whatever joint, it'd be easiest probably like with the shoulder, would be the well pump, and you would pump it like this for the range of motion, and it would, I think essentially we're going to have it fill up a bucket of water, and how we were going to gauge that is if you got close enough to a line or something, that's how it gets scored. That's no longer what we're doing anymore.
It's a very primitive implementation of a game that simply shows that ACESO works, to where essentially we're checking to see if this motion works.
The well pump wasn't so well received as the cherry blossom. First off, we needed something that was a little less system intensive, because first run of our program, our software, with just one system, just the data capture system, our frame rate was like 15, 11 at times, and you want it in the 30s. Hopefully around 30. The eye capture is about 30 frames a second. We were like, well, if we do the cherry blossom game or any of the other ideas we had, it's gonna just drown the system. Especially the way it is now. Now, in defense, the system's become much more optimized since then, so it's not running as slow. So maybe we could run something a little more graphically intense. But the well pump game came from, once again, can we develop something that has a motion to it that you can play with any joint or any limb, and pumping a well pump was one of those.
So now that all the individual components have been explained, let's talk about how it all works together. As we said earlier in the video, the ACESO project encompasses an API and the creation of a rehab video game. Now, these two components are designed to make rehabilitation easier on patients and physical therapists. So let's say you want to make a rehab game with ACESO. Instead of building all of the components that the team already built themselves, including the calibration system, the kinematic data management, and the patient safety system, it's already all right there for you. This will save developers a lot of time and a lot of work, helping the patients get the game faster, which in turn will help them get healthier faster.
And my research has always been focused around recording movement one way or another. We usually do it with very expensive lab-based system that is a set of cameras attached to the walls.
Previously, motion capture rigs, ran upwards of 10 grand. So, that's not the sort of resources that everybody can have access to. We're
trying to make it more affordable for everybody, because if it's the technology that's already out there, most of it's pretty expensive.
The Kinect is really cheap compared to other hardware that's out there on the market. At $99, it's almost a steal.
The Kinect was kind of the first technology that came out where we can take motion capture into people's homes and think of these kinds of applications.
It has a very well-supported community already around it, so there's a lot of people developing for it, so there's a lot of resources. You can plug it into a PC and it goes. PCs are everywhere, so it's well established. It's backed by Microsoft, so you're going to have great support, and it's readily available at low cost. The end goal of the project design is to create a community that is all about rehab gaming.
Physical therapy often is very tedious, boring, very hard. People have to repeat the same movement over and over again. How to make it more interesting? And of course, if the physical therapy exercises are more interesting, the people are more motivated to do them, then they will do them for longer. And we have lots of evidence now that the longer people do rehab, the better they get.
Games have actually been shown to increase improvement in therapists already. Systems like the Wii and any actual motion tracking games. And with the Kinect, you can do a lot more than with those systems. So you get a wider range of treatment.
It's been scientifically proven that when you're doing something energetic and something fun, that you'll be much more interested in pursuing the rehab.
Physical therapists are, of course, our primary clinical providers here. They would be the primary users of this technology.
Therapists don't really have any way to tell how a patient's doing other than through direct observation and what the patient's saying.
And that was actually one of the problems that we're trying to address, is there was no quantitative way to achieve that before. It was just, yes, I think you have a wider range of motion now. Now it's, yes, your range of motion has improved by 10 degrees over 2 months.
It's hiding the therapy behind fun.
The design project is providing this toolbox, the platform on which to build different tools. So the next step will be to build some of these tools and try them out in the field.
In that process, you kind of, it's kind of beautiful because you get this more efficient way of healing people.
I mean, it's going to open up a lot of doors for you if you're really into it, and you can further it because there's a lot of support here at WVU with our sponsors and everybody, and so they're going to try to market it. So if you get to a certain point in there when they actually do that, I mean, that can be, maybe job opportunities could come in.
It really sort of shows us how far technology has come, because something that cost you, multiple thousands of dollars, even a few years ago, now you can get something that's basically equivalent for hundreds.
I really would like to see it take off, see another senior design group come in and add their own ideas to it, put their own tools in the toolbox. That's where I hope it goes, and I see it going there as well. I'm really confident in what we have. I'm confident, with the work we've done, and I think you can tell that we're very passionate about this project, and I think that's what's going to be the driving force to make it a success.